If you don't know who I am, I'm Nick Siley. I'm a software developer in the Chicago Digital Marketplace Center. So today's Tech Talk is going to be about blockchain, distributed ledger technologies, and the future. So really I'm going to start off by kind of telling the story of how I got into blockchain. So early in my career at Dow, about the year was 2012, I was on the platform team, and what we did, we built servers and VMs for Dow's SAP system. And I joked a lot with the guys. We built servers and we heard about Bitcoin mining. We thought it was funny, like kind of a funny thing. So we did a little bit of math. We're like, how much would it cost to actually mine a Bitcoin? And we realized it'll cost way too much in electricity to actually do it. So we're like, we kind of just threw away the idea. We thought it was just some stupid scam thing. Bitcoin was about $20 per one back then. Now it's at its peak, it hit 20,000. So I kind of kicked myself for not actually mining. I could essentially be a millionaire right now. But after that, about a year ago, Chicago's a great place. That's where we're based out of now. There's very interesting people, and there's a guy who actually works at Avanade. He's Ukrainian. He was really into this Ethereum thing I heard of. I'm like, what is this thing? And he was more in the investment trading side. But really, I started researching about blockchain, the underlying technology, and you can kind of see there's a rabbit hole. So once you start researching, you just spend countless nights just kind of researching this stuff. But I actually got into it about a year ago, just doing a little bit of trading, then got more into the technology afterwards. So really a presentation summary. I'm going to start off with the Blockchain 101 video that'll really give everyone a really good high-level overview of what it is. Then I'm going to go into the components, the applications built on top of it, and then we're going to end with a little talk on cryptocurrencies, the future, and maybe possible DAO use cases for the blockchain.
The internet is cool, but it's also completely broken. Mass data breaches, phishing attempts, credit card fraud, and the massive wholesale shoplifting of your own personal information happening nearly every time you visit a website. Enter blockchain, the mystical, magical solution to all of these problems and more. Here's how it works and the problems it solves. Blockchain is the answer to a question we've been asking since the dawn of the internet. How can we trust what happens online? How do we control the data we put online? In simple terms, blockchain is a distributed database that maintains a list of records. These records are called blocks. Each block contains the history of every block that came before it down to the second it was edited. In effect, chaining those blocks together. Hence, blockchain. The other thing you need to know is that this whole operation is end-to-end encrypted. Every transaction is linked to a unique cryptographic signature that's easy to verify and nearly impossible to falsify, because blockchain is maintained by a scalable network of computers, often called nodes worldwide, which are in composite referred to as a blockchain network.
It's a network of computers that maintain this file, right, which is an append-only log of data. And the file itself isn't really interesting, but what's interesting is that you have all of these computers around the world that are coordinating with one another to make updates to the file in a lockstep fashion.
Blockstack is a startup using the blockchain to build a new, decentralized version of the internet where users control their apps, their data, and their digital identity with no third parties in the middle.
It's similar to the fossil record in that you can dig down into the earth in any area in the world and you'll see that the same layers occur in the Earth's crust, right? The same thing happens with the blockchain, where you can go back, any individual computer can go back into their own file that they have locally, and it'll be identical to everyone else's file. This is one thing that we haven't really had before. We haven't had a piece of data that was synchronized in a trustless way amongst an entire network of computers.
And that's the important distinction here. The fact that anything that happens only happens with total consensus across the distributed network. And that data is stored everywhere at once. That's also why you should trust blockchain, because blockchain gives you proof. Think about a basic digital transaction where Alice is sending Bill $25. To trust that exchange, what do you need? Alice needs to verify that her money went to Bill. Bill needs to receive that money from Alice. And the bank needs to log that Alice is $25 poorer and Bill is $25 richer. Blockchain does this without a bank or third-party service in the middle, using what's called distributed trustless consensus to prove that transaction is valid. In this case, trustless means the opposite of what it sounds like. Because of proof of work, it means no trust is required. Alice and Bill can both see their whole transaction on the blockchain exactly as it occurred. Blockchain's decentralized network and immutable ledger has universal potential. Companies are already using it for everything from banking and identity to tracking assets all over the world. One of those companies is IBM.
So blockchain is all about trust, ensuring that there's transparency, traceability, auditability, and immutability of those transactions. In particular, we're working with Walmart around food safety. The solution that we're working on with them is looking to increase the transparency and traceability of the food supply chain. And this really provides an opportunity to accelerate the time in which an outbreak may occur from days and weeks down to seconds. This solution has hopes of actually eliminating an estimated 30% of food waste across the food supply chain.
Another company IBM is working with is Everledger, a startup using blockchain to track and reduce fraud in the global diamond industry.
An example of an asset here is the diamond. How can you track and trace the history of that diamond, whether it be the cut, the clarity, the cost, who owns the diamond itself? You actually can have that validation or verification of where the diamond came from so that you can determine that it is from a conflict-free zone.
One of the coolest things that blockchain can be used for in the future, and this is the one that really blows people's minds, is a decentralized internet. Cue Silicon Valley joke. But seriously, same idea, better execution. A new internet that runs decentralized versions of all the apps we use today, and where you can do a whole lot more. So imagine if all the most essential services you use today, things like Amazon, Venmo, Uber, and Facebook, were protocols, open source frameworks, instead of being owned and operated by a singular corporate entity.
You can think about an Uber, right, that's decentralized. You no longer have those 20 to 30% cuts right in the middle. It also means that you have a high level of competition. So imagine if Uber and Lyft and Juno were all on the same network and were competing for those fees, right? So think about, you have Facebook, right? Maybe you don't like the fact that you have tons of advertisements in your feed, or that Facebook subjects you to what advertisers are paying to go viral, right? The fact is, if you give users freedom and you give developers freedom, you have a lot more choice, you have a lot better products that actually emerge, right? A lot more competition, a lot more experimentation. You have much lower prices, more actual economic growth, and more jobs that are created as a result.
So that's blockchain in a nutshell. Hopefully now you have some idea of why it's equally important, exciting, and really difficult to explain. That's really just the tip of the iceberg though, so if you want to know more about public and private blockchains, smart contracts, or anything else, check out our coverage on PCMag.com. The internet is...
Alright, so that's a pretty good video, and we're going to dive a little bit deeper in some of the concepts there. But yeah, to set the stage, just kind of think of a future world where there's a global identity, it's called Web of Trust, where you can really trust who you're actually transacting with online. It'll be easy, to deal with new customers in emerging geographies. Also think about the next thing. Think of a global data storage. Think of, you can actually trust the system that the data wasn't tampered with or forged. And that'll allow, potentially us to share data with partners and governments a lot easier. And think about automated contracts. Really it'll be easier to make deals with other companies in the future. So let's dive into some components of a blockchain. At the end of the day, like in the video, they said it's just a database, a public database. Some people call it a distributed ledger technology. It's more of a generalized term. But yeah, it's a distributed peer-to-peer network, list of ordered transactions. And it uses consensus algorithms to prove that something actually happened. To kind of dive deeper into that, what that kind of means is, let's say we have 100 computers, just the majority of them have to agree on the transaction order and the contents of that transaction. And the fifth component of a blockchain is it uses cryptography. Generally public-private key. You can think of a public key as your user ID, and the private key as your password. And every time a transaction goes through, it's digitally signed by you, so it's provable that it comes from you. So the last component of a blockchain is really one of the most important things for security. It's called a consensus algorithm. And that really solves the problem of like a double spend, like in a system like Bitcoin. You don't want to bounce a check. It allows for disintermediation, aka the removal of trusted third parties. That's how Bitcoin can operate without a bank. So to kind of compare that to current systems and future systems, if you really decompose what a current system is, and before I started doing research in blockchain about a year ago, this is all I knew. Our current systems, there's some PhDs out there who call it a leader-based system. And that's really what Facebook is. That's really what every system, anyone, even DAO, has made. You've got one company in charge of the entire system. You're in charge of the client, you're in charge of the server, you're in charge of the database. It's a typical architecture. And at the end of the day, data can be forged and abused. You see all the fake news and the Cambridge Analytica scandals going on right now. And there's really no consensus algorithm. The consensus is a dictatorship. If I were to go to Facebook and post something, let's say I love puppies, there's nothing saying a system engineer at Facebook or even Mark Zuckerberg could go to the MySQL database and forge that transaction and say I hate puppies. The whole world thinks it hates puppies. discriminated. There's nothing against it. They obviously have internal policies, but technologically speaking, there's nothing saying they can't forge that system. And if you look ahead at some of the future systems, future architecture, blockchain systems, they're distributed. So I forgot to tap into a DDoS connection or DDoS attack. Applications like Facebook today, every day they're getting DDoS. They use companies like Cloudflare to kind of try to mitigate that. But really, when you're running one server, one cluster of servers, that's one spot you can attack. On the contrary, blockchain systems are distributed. There's millions of nodes around the world. They all have a copy of this data. There's not one person you can attack to take down the network. If you've ever on Christmas Day wanted to play a game or watch Netflix, usually that's when the bad guys try to stick it to us here in America. They like to take down our systems on Christmas Day. So that's just a DDoS attack. It's just because our current systems were built like that. Another attribute of a blockchain system is really the architecture is different. You still have your client, so you have your web app or your mobile app. And instead of talking to one single server, you generally talk to a smart contract. You think that as back-end code. We're going to get more into that later. And then at the end of the day, instead of a database owned by one person, it's usually a blockchain ledger. Data can't be forged, digitally signed, and consensus algorithm is really the key to all of this. I'm not going to go into that, but there's many. You should do more research. The one's called proof of work. That's what Bitcoin uses. Newer systems, it's called proof of stake. And it's fascinating stuff. And Blockstack is the guy from the video. He's one of the companies. They're a startup trying to build this architecture. So the next big component of what a blockchain is, there's two different types. There's a permission and a public. So a public blockchain is obviously Bitcoin. Anybody can participate. It's global. It's kind of like the internet. And the second classification is a permission network. And that's where you have to be invited in. So IBM has a bunch of permission networks. For the origin of food case that Walmart did, you have a farmer runs a node, the supply chain guy runs a node, Walmart runs a node, and they all vote on the order of transactions, and it's kind of a public database. You have to be let into the network. Pretty similar to an intranet. And a Hyperledger project is a Linux foundation. They're trying to develop an open source blockchain that anybody can take and build a permission network on top of. The evolution of the blockchain. So really it started in 4 generations. That's kind of what they're classifying it into. The first one most people are familiar with is cryptocurrencies. That kind of started around 2009. There's a whole mysterious story about this guy, Satoshi Nakamoto. Nobody knows who wrote the white paper that kind of sparked this whole blockchain revolution. But Bitcoin was really the first app built on top of blockchain. People just kind of abstracted the blockchain technology out of it. And at the end of the day, all currencies could do in 2009 was just add and subtract. Very, very simple application. Has scalability issues with proof of work. You can only do about 7 transactions per second. Then it evolved into ledgers. So they opened Bitcoin up and allowed you to store a tiny amount of data on that. So instead of just doing number transactions, you can maybe store 32 characters of any kind of data on this global database, which wasn't too interesting. And then 2012 was really when the revolution started to break out. There's this guy, Vitalik, who created this system called Ethereum, and he wanted you to be able to program the blockchain, store anything on the blockchain. And that's really the 3rd generation here with contracts. And the 4th generation is what I'm personally interested in, is dApps. If you don't know what the word dApp means, it's just a decentralized app, or some people call it a distributed app. There's several companies trying to work on that problem. They're pretty far along. EOS, IOTA, and Hashgraph are the 3. And they're trying to solve the scalability problems. They're using a lot of the technology used in some of the Visa networks, and they actually get hundreds of thousands of transactions per second. And there's a lot of use cases once that system is live. EOS comes live this summer. IOTA is kind of live, kind of in a beta state right now. And Hashgraph, by the end of the year, they're supposed to have a public network. But really, stuff you can build on top of it, they call the 4th generation markets. Really, I think of it as decentralized apps. But you can build all these supply chain apps. I know Dow's actually working on a supply chain app right now, but more on a permission network. But it's going to be possible to do this on a public network coming within the next couple of years. You can do decentralized exchanges. You can do gaming. So it's kind of interesting to think you can store. Let's say you're playing like a game like Halo. Somebody moves or somebody shoots somebody. Right now, you trust that back-end server. You trust that people aren't cheating. Think of a future where you don't have to trust a server or a company. You can put that move on the blockchain. Everybody can verify it. it kind of changes the game. Like the video said, we'll be able to rewrite apps like WhatsApp, Telegram, Facebook, all in a decentralized fashion. Data marketplaces is cool. I'm going to get into that later. So smart contracts, that's really generation 3. All that is code that lives on the blockchain. And this is an interesting project I came across. All this code you can just read online. This is an Ethereum smart contract. It's in a language called Solidity. It's a JavaScript-esque language, but you can't really have a hackathon without showing a little bit of code. So this is an interesting project called Smart Vow. So you can get married and put it on the internet. So for $29.95, you can get married, you can put a will on the blockchain, you can get divorced on the blockchain. You can even get your wedding picture stored on IPFS, which stands for the Interplanetary File System. It basically uses the blockchain to store a hash, which is a small byte of data that replicates what the actual big file is stored somewhere else. I thought it was just really interesting. It's 286 lines of code, very simple to follow. You can see, some of the functions are, update your partner vows, add a life event, update marriage license. There's one I think called get a divorce at the bottom. And really, if you kind of decouple this and think about it, when two people get married, they go, pretty much to a courthouse. They have, partner 1, partner 2, a witness, and then you usually have somebody who works for the third-party intermediary, which is the courthouse. They sign a piece of paper, notarize it, and then the state and country you're in kind of verifies that you're married. So this kind of takes away that third party and puts it on a blockchain. So if somebody in some other country wants to see who's married, it's fairly easy now to go to a blockchain. Like, has anyone actually verified that their parents are married? Like, where would you do that? Go to the courthouse, look at a newspaper? I don't know. I've never tried to do it personally. And Solidity gives you kind of a nice user interface written on top of it. Right here is a smart vow. So somebody would go to the website, fill out a form, pay $29. They'd get their witness, and they just fill in all this data. And the important piece here is this contract data, the address here. So this big, long string, it kind of looks like gobbledygook. That is essentially a public address, which you can think of as a user ID. So at DAO, for me, this would be U402046. And then to prove that, I type in my password, which is the private key, and that verifies my identity, and I can fill out my data. Same thing with your partner, the contract owner, your witness. They verify their identity the same way.
So Nick, on something like that, how do you? So I understand how this kind of validates that transaction was stored and it was and it's unchangeable.
Uh-huh.
But how do you actually validate that the marriage took place?
You
I'm
just
not going out there and picking a person and saying, okay, we're married.
You just got to think about how it works today. How do you validate a marriage today? You trust a courthouse. You trust they did their job. Have you ever actually verified somebody was married, like your parents, somebody down the street? How do you do it today? So you can kind of think of it as that. But yeah, at the end of the day, you just trust this. You trust the courthouse system. In the future, you just trust this blockchain system, and you verify their user ID as them. In a lot of systems, like Blockstack is a system. So that doesn't mean anything. They're making a system to route that to a human readable name. So I could be nicktiley.id, and then you can even verify it even one more step. There's companies working on this where they add proofs, where maybe I take a picture and make a video or put my thumbprint or do a biometric, and you put that other layer of proof on top of that.
Mm-hmm.
And Microsoft has a project called, I think, Identity 2020, where they're taking, I think, Syrian refugees who don't have an identity, but they need to get out of the country. How do you identify somebody? You can't just trust whatever name they give you. So I believe they're just putting some kind of biometric on the blockchain. You can't really replicate a thumbprint. So if you stick that biometric on the blockchain, it's kind of a way to verify someone's identity.
So there's a physical event. There's a physical attribute that they can verify in that case.
There's a lot of events you gotta have trust, a physical event, and
But like on a marriage, how do you?
Is it the partner 1 and 2 address that you're?
Yes. So there's 3 humans being involved: partner 1, partner 2, and witness. So and those are all 3 different public addresses with 3 different people. So you just verify those on the blockchain. It's kind of an abstract concept, but it'll make more sense in the future once you start seeing some of these.
And I'm just trying to tie the connection between the physical event and the digital event. right? Because then you can extend that to say, okay, well, did I actually receive shipment at my warehouse, right? You may record, somebody could fraudulently record that you received shipment, but the shipment's been diverted,
Yeah.
elsewhere, and you're selling out of, selling out of
Yeah, in
dock
that
to the
place,
black
if you're talking
market.
about like origin of product, you probably
Yeah.
have digital checkpoints, an RFID on the project to do it. But yeah, if a breakdown happens where the sensor's down, there might be a lapse in that thing.
Yeah.
So yeah, there's still some trust you got to put into the systems. It's not a foolproof thing. You still got to have physical enforcement. So you probably still have to have your police department if somebody's not paying their bill, or somebody, you see somebody got married twice. If it's not big, you probably still have to have a physical local enforcement, like police or obviously local government.
Yeah.
Yeah, so that's not going to go away. It'll just help automate the process. Maybe take away some of the third parties in between to make it cheaper to do. This is another smart contract I found out on the internet. And it's for decentralized exchange. So there's an exchange called Ether Delta, and in 312 lines of code, they replicated what essentially the New York Stock Exchange does. How many lines of code is in the New York Stock Exchange? I don't know. It's probably a super complex system, but it's fascinating to see that there's stuff like the order book. You can withdraw, you can transfer a digital asset to somebody, you can trade. It's all 312 lines of simple JavaScript code. People transact on Ether Delta billions of dollars worth of assets. It's kind of amazing in 312 lines of code without trusting one company. Billions of dollars is flowing through the system. So the next awesome thing you can build on top of identity is kind of what we've been talking about, is self-sovereign decentralized identity is what it's called. And there's actually a W3C spec out there. Microsoft is one of the big partners of it. And really that's kind of what I was talking about, putting your identity. You're probably going to have multiple factors of proof to have that actually work. But this could help in the future with knowing your customers. Dow is a pretty highly regulated industry. Certain chemicals can be only sold to certain people. We get in a lot of trouble if we sold something to ISIS or something, I'm sure. So they're starting to come up with know your customer progress, some kind of stuff with regulation. And you can think of identity as similar to Facebook login. Right now, when we log into Facebook, we trust Facebook. We trust they don't forge our identities. If they go down, our identity goes away, which is kind of scary. Similar with Dow, Dow has our credentials, stored on Azure Active Directory right now. If Azure Active Directory went away, where does our identity go? So think of a future system where you own your identity, like it's yours, not Facebook's, not Twitter's. Nobody can forge your data. And it's interesting that Facebook just announced they're starting a blockchain group actually in Facebook. And my hunch is they're going to investigate some of this identity stuff to help fight fake news. How do we know who the advertiser really is? Because anybody right now can sign up as an advertiser on Facebook and put anything they want as long as they have money. How do you actually identify somebody, especially in a global system like Facebook? Somebody in some small country in Africa who might not trust their government. How do you do that? I think that's what they're really going to investigate this year. And a really cool thing you can also build on top of blockchain is open data marketplaces. So if you think about our current systems today, all of our data is kind of stored in one spot, which is scary. Cambridge Analytica and Facebook scandal. You've got Equifax, exposing all of our social security numbers and stuff like that. It's just kind of a bad design to have everything in one spot. And especially with Europe right now, they're cracking down on that. The General Data Protection Regulation, if you haven't heard of that, it essentially says users have the right to their own data. So in Europe, if you're on Facebook and you want to actually delete your data or be right to be forgotten, legally Facebook has to delete it from their MySQL database, all their logs, completely gone, no logs, no records. So that's starting to happen even on Azure right now. I know I got a notification saying they're starting to roll out GDPR, and it's not just Europe that has to abide by the rule. If you're a company in the United States and you're servicing customers in Europe, you have to abide by the GDPR rules. And really, in the future, the data really should be split up into a lot of different places. You should have your own bucket of data. You should have your own identity. You bring that data to the app and consent the app to use that. So that's kind of, once you get into that, you can have kind of a more free economy. Some people call it an open data marketplace where you still can sell your data, except you'll get a cut of it. maybe the server provider like Facebook will get a 25% cut. Maybe you'll get 75% of your data. There's people out there, I think they've done the statistics, an average person, it's about $1,000 per year is how much your data is worth across all the networks. It's how much they make selling your data to all these different companies. So that's a lot of data, a lot of money that should actually be distributed amongst the users of the product. Some people say if you don't pay for it, you're the product. There's a huge ecosystem of blockchain projects right now. There's obviously currencies like Bitcoin, Ethereum. There's data marketplaces like IOTA, Streamer. And the one that's kind of interesting on this slide, you can kind of zoom in on your own time and kind of research some of these projects. A lot of them are really interesting. There's kind of off-the-wall things where people are trying to build countries on the blockchain. That's kind of crazy. But the one I'm interested in is basic attention tokens, a cool one you should research. So Brendan Eich, he's the inventor of JavaScript. He created the Mozilla Foundation, a lot of stuff with the early internet. He actually thinks the internet's kind of broken, just like Tim Berners-Lee as well. Like a lot of sites are just funded by advertisements. You go to any New York Stock, any news site, you just get ads. Like it's crazy. And it really on your mobile device, every month, half of your data plan is because advertisements and tracking cookies. You don't know you're paying for it because you think it's free, but you're probably paying $5 a month in just those advertisements sucking your network. So he's trying to figure out a different way to monetize the web. How do you monetize content producers on the web? He's using some different techniques with blockchains and tokens. It's not super clear right now, but there's definitely a future in that. So you can't really talk about blockchain without talking about cryptocurrencies. So if you're not familiar with it, they trade sort of like a stock. It's highly speculative. Some people call it gambling. I think it's fun. You can go to a bunch of different exchanges. Coinbase is one that's popular here in the United States. And at the end of the day, it's actually a serious market. The Mercantile Exchange in Chicago, they actually trade Bitcoin futures. There was an article that came out, I think, today that there's rumor that the New York Stock Exchange is going to either trade Bitcoin firsthand or they're going to do futures on top of it. And you've got the Winklevoss twins coming up with the Gemini Exchange, which they're aiming at institutional investors. So there's a lot of big money that's going to come in. You see the market cap over here. In the month of January was kind of when the bubble was at the top. And it was over $800 billion market cap for cryptocurrencies, which is pretty big for a new market. And they think it's going to hit $1 trillion this year. And if you bring in institutional money, it's going to kind of blow up from there. And there's a lot of good information on coinmarketcap.com if you're kind of into the trading and stuff like that. I kind of learned a bunch of stuff. Josh over here taught me how to do a little bit of technical analysis. So if you kind of read these charts, there's patterns you can kind of form to see, buy low like Warren Buffett says, sell high. It's just kind of interesting to get into. It's sort of like gambling, but I think it's fun. So yeah, this is my last slide. It's really just, they talk about in the World Newscast this morning, build the future, build the new DAO, build the future DAO. So yeah, I just encourage everybody to embrace new technology. Talk to as many people you can. Chicago is awesome to go to meetups. You meet interesting people that kind of plant weird ideas in your head that you research. Yeah, do proof of concepts on early technology. Think about how DAO can actually build on this. There's a bunch of supply chain use cases already kind of in the works. Think about how we can reach new companies, customers, even in the future. Maybe it's 5 years out. There's no reason we can't think about it and brainstorm it now. Self-sovereign identity, I think, will be key to a lot of emerging technologies and countries. Think about, AI and ML. Think about the machine economy. Think about a plant buying something from another plant and an autonomous vehicle moving that product without humans involved at all. Think about a car charging at a car charger. The car pays the charger. Stuff like that. I really think about disintermediation. Think about how many people are in between the customer and the producer. Are they taking 20 or 30% from us that we may not need them anymore with this automated system called the blockchain? And down at the bottom, it just says kind of hello future. There's a lot of companies building this trust layer of the internet. And I think, by this end of this year, there's going to be some major scalability enhancements on top of public blockchains. So yeah, everybody have a good hackathon and hack away. Questions?
So,
one is, so you were saying that the distributed network is essentially a peer-to-peer network, right?
Yep.
So if these blocks can have code in them as well, how do you prevent, essentially circulation of malware and things like that, like you saw with a
Yeah.
LimeWire?
Yeah, so if you're talking peer-to-peer network, as in LimeWire or Napster or some of those older systems, they had peer-to-peer in the sense that, but it wasn't it wasn't trustless. You basically could transfer anything. There was no consensus algorithm to actually prove that the data that was flowing across the network was valid or not. So it's a different type of network. It's based on peer-to-peer and the fact of transferring data, but not how the security works. So yeah, the best answer is just research how proof of work consensus algorithm works, and then some of the new ones are proof of stake. It's kind of an interesting way to do it. It's kind of hard to explain and deep dive into, but yeah, it's consensus algorithms.
Okay, but if someone was able to take control of your machine or something and became you, and it wasn't
Yeah, so if you're
malicious
talking
actor.
about attack vectors, there's Sybil attack, there's the 51% attack is probably the most known one. So basically in Bitcoin, there's millions of nodes. So if somebody got a hold of over 51%, yeah, they could forge the network. But to do that, you'd have to be richer than the richest person on earth with the fastest computers. So economically, it's impossible to do.
So it's not like it's not one malicious actor.
It has to be
infect
over
the network.
51% of the network. That's why Bitcoin is the most popular network, because it has the most, they call it hash power. It just has the most security because it has the most nodes confirming this stuff. But yeah, it's really just the consensus. Most people are honest, and if they're dishonest, they get penalized by it. For Bitcoin, it's just you got to pay money to achieve the network.
Gotcha. My second question. So I think I understand the whole concept of blockchain and the application, but where do you see something like this impacting or disrupting a company like SAP that we use today?
Yeah, I think really if you're a company that your whole job, like bankers, obviously that's kind of the first, maybe accounting. Anytime you're kind of a third-party auditor or a third-party intermediary, that whole industry I think will get shaken up first. SAP, if you're specifically talking about them, they provide like enterprise software. They could adopt their technology and maybe store some of that on blockchain. I could definitely see somebody like SAP embracing the blockchain.
I'm just saying, if we built a blockchain infrastructure here, could it replace essentially what SAP is doing for us today?
Yeah.
As far as tracking transactions.
Yeah. Funny you asked that. So my hackathon project has to do with a lot of this stuff, but my idea, you'll see later, kind of is along that theme right there. So yes, they can definitely do that.
I'm sure it varies by application. I'm just curious, I'm seeing all this and thinking latency, like as far as the time a transaction actually occurs to the time it propagates to all the nodes and it's universal.
Yeah, so there's two different things with latency. The first is just purely propagation. The second thing is how long does it take to actually come to consensus that it's actually true. So today, Bitcoin's extremely slow. It takes every 1 second, there's only 7 transactions that come to consensus. So it can only do 7 transactions per second. That's why people are starting to say it's digital gold. We can actually buy coffee with it. And that's really just because that's Gen 1. Gen 2 was Ethereum. They did a little bit better. They're about 15 transactions per second. They're highly latent. The systems today, you're not going to put a real-time stock exchange on. The 4th generation system, that's where you can start thinking about stock exchanges or a real-time order system. And they really changed that consensus algorithm. They don't use mining. They have a whole different thing. One of the algorithms is called hash graph. Another one is called proof of stake. And those really bring the consensus time down to variable amounts, but within 1 or 2 seconds you can have consensus. So these systems are going to have more latency than our current systems, kind of our leader-based systems. But really you get a ton of security benefits on top of it. Most systems can handle 1 or 2 seconds of latency to prove that a transaction happened. There's Hashgraph is a company that the guy did a few proof of concepts where he built a real-time stock exchange, where within 2 seconds you can have consensus that a transaction, a trade actually happened. He did the same with the game. He made a shooter game where people shoot each other and people get shot and they disappear. But sometimes the with the latency, it might take a second. So gaming's still a little bit far-fetched, real-time gaming. But yeah, if your system can handle 1 or 2 seconds of latency, in the future it'll be possible to build stuff on top of it. Anything else? All right. Yeah.
What's the difference between a decentralized network and a distributed network?
Oh, there's a good graphic out there about that. But yeah, you've got obviously centralized, where you have a node and people talk to that one node. The next picture, there's actually a really good visual I would just show you. Decentralized, you usually have a bunch of nodes and clients talking to it. And distributed is basically you draw the lines to every node. Everybody talks to everybody. So yeah, it's kind of the 3 different systems: centralized, decentralized, distributed. Just Google it. There's a really good graphic out there. Kind of is better than me explaining it.
Yeah. What if someone makes a mistake when they put an entry in that marriage license one? Someone spells their name wrong and they put in the wrong name or something like that. If it's immutable.
Yeah, it depends on how you build the system on top of the blockchain. So yeah, it depends on how you build it really. And at the end of the day, your identity is not actually a text field you put in. Your identity is your public key, your DAO U40206 for me. So your identity is there. It's just maybe the name that you spelled in a certain parameter is wrong. Where it depends on how you build the system. There are systems like EOS. We do allow it. Like people are going to make mistakes and bugs. You know, we're going to it's built into the system that you can edit stuff. Other systems like Bitcoin, you can't. You don't want somebody to edit the amount of money that you go back in the future. So yeah, the blockchain is pretty general. It's how you build the system, and then really when you write the code, the code's going to be public in certain systems, and you just got to review the code. So it depends. All right. Thank you.
Cool. Thanks, Nick.
Thanks.